All right, ladies and gentlemen, so you know that we can't talk about the cell membrane without talking about this concept of homeostasis, the ability of a living system, a living thing, of which the cell is the most basic unit, to maintain a stable internal environment. That's what homeostasis is, and the cell membrane, the plasma membrane, the lipid bilayer, whatever name you want to give it, helps the cell maintain this very, very crucial state. Here's our definition. We know it's the balance that organisms maintain through self-regulating adjustments. And mainly, even with you, all right, you and I, we maintain homeostasis by taking some things into our body and excreting other things from our body, like waste. The cell does the same thing. The plasma membrane is what prevents some things from getting in and some things from getting out. Whereas you and I, it's our mouths, right? Or what we want to consume. That's how we maintain homeostasis, and our cells do it via their plasma membrane. Now, you have to think of the cell as an open system, okay? I know it has that plasma membrane around it. I know it's made of lipids, and it's really good at not interacting with water to keep the cell from dissolving, but things are constantly flowing into the cell. Things are constantly flowing out of the cell. It's an open system. It's just not everything gets to travel through the cell membrane, and not everything gets to travel outside of the cell. Now let's talk about this permeability of the membrane, this ability to be semi-permeable, to let some things in while keeping other things out, and why that's so beneficial for your cells. Now, again, we call the cell semi-permeable, or you could call it selectively permeable. Either one, semi or selectively, however you like to describe it, or whatever sticks in your head best. The membrane basically picks and chooses what gets in based on its chemical composition of lipids and how close and compact they are, or what proteins exist within that plasma membrane to allow certain molecules to shuttle through the membrane. Oh boy, we have a formatting issue here. And again, this right here just says that the ability to let some substance pass through readily or easily than others, while also allowing some materials not to enter at all. That is the definition of semi-permeable or selectively permeable, as you see on this slide. Now, let's talk about this in real time, okay? What happens when you have fluid on one side, which is the cytoplasm inside the cell, and then you have fluid on the other side, which is the water-based environment on the outside of the cell? And we have this situation kind of depicted here, and divided up the middle is the cell membrane. Now, when something like this happens and you have substrate molecules or anything in water, right? Substrate's the stuff that gets dissolved, like these little atoms here. It creates a concentration gradient. Okay, and what exactly is a concentration gradient? Sorry about the formatting issues, but in the absence of other forces, so in the absence of energy, the way things will go naturally, the way things will just move naturally, like these atoms, is they will go from an area on the left here, where they are highly, highly concentrated, and they will naturally move to an area over here where they are low in concentration. This is all in an attempt to create something called equilibrium, right? To be equal, to be evenly spaced and equally spread out. So we have our cell membrane dividing these two environments, and we have the area of higher concentration on the left of these purple atoms, and we have an area of lower concentration on the right for these purple atoms. And now I want you all to think, before I go ahead and show you, what direction, in the absence of any other forces and assuming that these purple atoms can travel directly through the plasma membrane, do you think that these purple atoms are going to go from the left to the right, or they're going to move from the right to the left? 100% right, because the definition of a concentration gradient states that in the presence or lack thereof of other forces, materials, molecules, tend to move from an area where they are highly concentrated to an area where they are lowly concentrated. So we are going to move our purple atoms that way, following a concentration gradient, high to low. Now we see this same situation happening in the drawing on this slide, although here we see a different representation of the plasma membrane. Okay, and here we see different solute or substrate molecules just floating in water. We see we have a cell membrane here that looks much more like our lipid bilayer, a much more realistic cell membrane. And we have panels A, B, and C, which depict changing environments. If you look at it from left to right, we see solute on one side. Then we look at B and we see, oh, some of it's made it into the cell. And then we look here and we look, oh, now it looks like it's equally distributed outside and inside the cell. So in A, we have a higher concentration of solute molecules on one side of the cell membrane. In B, via the concentration gradient, the tendency for molecules, materials to go from an area of high to low concentration in the absence of any other force or any other energy, we see that these solute molecules, where they're highly concentrated, they begin to just naturally move. And because these solute molecules in this example can just pass right through the lipid bilayer of the cell membrane, we see them moving from an area of high to low concentrations in an attempt to achieve equilibrium. Now in C, equilibrium has been reached. We see an equal number of solute molecules on one side of the membrane as we do the other. Now keep in mind, this doesn't mean that those molecules are just done moving, right? The molecules here aren't just going to stay over here, and these molecules here aren't just going to stay here. They're going to move back and forth through the cell membrane, but they're going to move back and forth at equal rates, meaning that once this equilibrium state is reached, movement still occurs. It's just that if one or two of these molecules move in, one or two of these move out in an equal fashion, and that is equilibrium. Equilibrium does not mean the stoppage of motion. Catch you in the next one.